Okay, so in the last training, in the last session, we talked about um, what is. Let's open the GitHub link. Why it is not here? Terraform. Let me just open this one. Delete and import it. Here, just import. And while it is opening, let's open this one. So, so in the previous session, we talked about um, outputs. Okay. So the output block, right? So how do you write how do you print the output from Terraform plan, apply all this thing, or take something from the state. So output doesn't do like it's just go and search for the state, and whatever you are requiring, it just find out that and print it in whatever desired form you want. Okay. We talked about variables, how to use variable, declare, reference, okay, and uh, formatting. Okay, formatting. We talked about conditionals. Okay, we created using ternary operator. We have a ternary operator implementation in Terraform, which you can use to set uh, define like if the resource you want to create or not. Okay, operator. Okay, we talked about loops. So we talked about count and for each. Okay, so these two are the the way you can use loops. Okay. What? Come on. It's fine. Fine. Loops. Won't allow me to change it. Okay. And we talked about providers. Okay, like AWS providers. Uh, we didn't talk about random. Okay, random is something that generates some the name randomly. Okay. So there's a provider random as well. Okay. Just to give you an example. So if you don't want to name this, name something like, okay, let me just say, I want to use the name of the instance randomly. Okay, so what I can do is I can prefix the instance name using a random thing. Okay, so what I can do is you can just create a resource. Okay, and it's a random resource. Okay, and let's see how do we use random. Okay, so random Terraform. Okay, so random is a provider. And what does it do? It gives you some randomness. Okay, so where do you use randomness? So let's say you want to create a resource, okay, and you don't know if the resource exists uh, or not. Okay, so what you do is you give it a random name, okay, and some suffix so that you can know that this is created by you. And this way, the the name of the resources will always be unique. Okay, so you can attach some randomness in the naming so that it will always be created, always be updated. So that you don't need to worry about if the name exists there or not. Okay, so how do you use random? So you use random like this. Okay, so let me just copy this and we will use uh, this in our uh, theme. Yeah, okay. So I just copy this code. Okay, I can just remove this. It doesn't require. Okay, and this can be you can use random ID for passwords. You can use random ID for username so that whatever user you're creating, it is always random. Okay, and I will use this random name prefix. Okay. And I'll use this name prefix in my EC2 instance so that whenever it is get created, it will always be using some random name. Okay, so name, sorry, it's a resource, right? Random ID dot name prefix, okay, dot I think it's a value. So just to confirm, we can go to docs and how do you use random ID server, and it says keeper ID. No, not like this. We will use server dot hats, server dot value we can use. Okay, so we can go to resource and you will see random ID, random integer, random password. You can also get a password, random pat. Pat is nothing but a random pat name. Okay, so this is something I'm seeing for the first time. Okay, so you can get random string. It will give you some string that you can use. Okay, random ID will give you some ID like kind of thing like a hexadecimal number. Okay, let's use some random string because we are using for our naming. Okay, so what I'll do is I'll just go and paste it here. Okay, the length I will reduce it to 6. Okay, no special, and override is also not required. It is not required. It will generate a random zero. Okay, so I will just name it like name prefix. Okay, and how to use it. So what? So how do you use it? It gives you the output. Okay, so schema. Okay, and what does it? Uh, so how do we use it? It doesn't show how to use it. Random is string. Dot specify. Okay, so value thing, and let me just plan this one and see if it works. Okay, so what I'll do is I have used army ID, EC2 instance, VM stack. Am I using anything? No, perfect. Okay, so it will create 3 machines. Let me just reduce it to 1 so that I don't need to create 3. So here I will do Terraform init. Okay, why I'm doing Terraform init? Because I have used a new type of resource. Okay, so random string is not part of AWS. So this is part of a random provider. Provider is named random. Okay, if you don't do init, if you directly do plan, it will say I don't know anything about random. Okay, let's see if it really fails or not. Okay, instance name it is asking. Okay, so let me just stop this here. Okay, in the last class we created a tfvars file right here. Okay, in Terraform, if you name this tfvar file like this, it will automatically pick this variable files. Okay, so you don't need to add this as a var file here. Var file is equal to terraform dot tf dot tfvars. Okay. So if you name the Terraform var file terraform.tfvars, it will automatically pick it. Okay. It says inconsistent dependency lock. Let me just delete this lock. Delete permanently. Okay. So just rename. Now it says you see the error, right? The following dependency selection recorded in log file are inconsistent with current provider. The provider AWS required this configuration, provider random required this configuration. Okay, so it says you have to initialize the dependency log again. So how do we do it is using Terraform init. So in any Terraform flow, you do init, plan, and apply. Okay, so we have to do init always, and there's no harm in doing init all the time. I'm just doing initialization. Okay, and I'm just doing a Terraform plan. So reference to undeclared resources, which one? Name prefix has not been declared. Okay. So name prefix is here. Oh, sorry, random is string it is. Okay, I bet. So I'll just close it here. I'll just make it like this, and I will just plan it again. Okay. Okay. So let's see what are the exported values. So I go here, I go here, and in the documentation, I should see how to use this value. Okay, result. So we can use result here, dot result, and now if I run plan, I should see something. So when you you see the random name is getting generated here, it says name prefix will be created, and the name will be known after we apply the random prefix. Okay, so if you see here the name, right here ID, it says known after apply. Okay, even if you see the name, okay, tags will be known after apply because it depends on the random string. Okay, let us apply here. Okay, and you see that it is not asking us any prompt or not, it's not asking us any the variables we have defined. Okay, so here you see random string name prefix creation completed, and it says GBBU. Okay, so this is the name of this is the random name it random string it created. Okay, and now if you do a plan again, okay, it says no changes. Okay, so this random string when you try to create, it will only create when there is a change. Okay, change in this thing. Okay, so what if you say I want to change it with whenever there is a change in the uh, AWS instance. Okay, so whenever AWS instance changes, it will also change the random string as well. Okay, whenever the environment changes, environment value changes, you will generate a new random string. Okay, and if there is any there is no change in the defined properties, the random string will not change. Okay, and that you can you can set this using the keeper here. Okay, so keeper is nothing but the values, okay, that will decide if I need to if Terraform need to generate the random string again. Okay. uh, but again, like this is one of the provider, there are many other provider that you can leverage in Terraform. Okay, and that is dependent on the kind of work you are working and kind of project you are doing. So fine. Okay, so I'll just delete this random string. We don't need it. Okay, I can just call it Honeywell. Okay, and just let's a hyphen. Okay, I'll just create a apply directly, and it's this time I will say auto so that it will not ask me anything. Okay, it will just do it. Okay, it says I will delete the random string because it is not defined in the Terraform code. Okay, done. Okay, so yeah, we wrote EC2 file. Okay, we wrote providers.tf. We have a Terraform state here. We have a TF files here. Okay. Now let's see how you can organize Terraform code. Okay. So when you create a Terraform code, your and you have many resources in your code. Okay. Um, you might you might be forced to split the one file into multiple files. Okay, so how do you split your files into multiple files? There are standards in Terraform to do that. Okay, uh, so the one standard is file structure. Okay, so main.tf file. Okay, this file contains starting code. Okay. So in Terraform, there's nothing like starting, like it will just read all the Terraform files together and it will try to find what is required to create what. Okay. So when you so if you know, right, when you create a EC2 instance, okay, okay, you have to define networking and all things, right? Which VPC it want to use, in which subnet it want to use. If you don't specify that, it will take the default VPC and default subnets. Okay, but if consider a fact when you have a separate VPC, okay, separate VPC, and in that VPC you want to set up EC2 instance. Okay, so this is your EC2 instance. Okay, so you create a VPC. Inside the VPC contains the subnet. Okay, maybe multiple subnet. Okay, VPC also contains routing table. Okay, it contains internet gateway, IGW. Okay, the VPC also contains NAT. Okay, for a private instance. It also contains elastic IP. Okay, to access the internet, right? So internet gateway will be associated with the elastic IP so that you can access the EC2 instance. So the VPC will have multiple components here. Okay, and how do you set up this kind of infrastructure from AWS? So what you will do is you will create resource AWS VPC. Okay, and you say my VPC. Okay, and same thing you will apply for subnets. Okay, and when you create a subnet, VPC subnet, you will define that I need to use VPC ID to resource AWS VPC dot my VPC dot ID. Okay, so you have to define VPC ID where this subnet will be created. Okay, so you see this VPC subnet is dependent on the VPC created here. Okay, when you create routing table, the routing table have subnets. Okay, so when you create a subnet, when you create a routing table, you need to associate it with a subnet. Okay, so when you create a routing table, you define which subnet to use it. Okay, so when you so there is a dependency between one element to another element. Okay, and how do you set this how do you see this dependency? Let's say this is your VPC. Okay, VPC is your top level object. So VPC have subnets. Okay, VPC have routing table. Okay, VPC have internet gateway. Internet gateway depends on elastic IP. Okay, so somebody need to get elastic IP first. Okay, subnet depends on routing table depends on subnet because it defines some subnet to be applied on. Okay, so VPC also have a NAT gateway. Okay, so NAT gateway is for internal network, but it also requires a internet connection. So it connects with internet gateway in some sense, and then it gets the internet connection. Okay, so this is the internet. Okay, so there are dependency here. So you cannot create a NAT gateway unless you have a VPC. Okay, so when you create a Terraform code, okay, let's start creating something good here. Okay, so where I will say app infra.key. Okay, so in this code, okay, what we will try to do is we'll create a VPC. Okay, we'll create a subnet, and we will create everything in a new network and EC2 instance in that network. Okay, and in that way we will know that what all things we would need to set up the infrastructure. Okay, um, so let me just delete. Okay, so okay, let me speak. So I will just comment it out. Okay, all of this thing. So what I'll do is I'll start with a fresh code. Okay. So what we will do is our main code will contain the starting code. Okay. Our output.tf as you know, it will contain outputs. Okay, we haven't. So until now, we use same file for keeping all the resources. Okay, and let's see how we can organize this code in a better fashion and how we can make this a readable code. Okay, so what we are trying to do is let's AWS VPC with EC2. Okay, so I'll go to this image. Okay, and what we are trying to do is we will try to create something like this. Okay, so we have a region. Okay, inside region we will create a VPC and we will create an internet gateway. We will create a subnet. Okay, and in that subnet we will set up some sorry, this one. Okay, so we will have some servers, private EC2 instance. Here we have subnets. We will create subnet. We will create a VPC. Okay, and this is a internet gateway. So we will create an internet gateway. We will create a NAT gateway as well, so that they can these two instances can access the machine. Okay, so let's start creating it from fresh. Okay, let me just okay. This is including control. Uh, where is here? Okay. So what we are trying to do is I'll create another AWS infra.md. Okay. So here what we are trying to do is our goal is to set up a new machine in a new VPC virtual private network. Okay. So for virtual private network, we will choose as region as US East one. This is the most costly, like least costly, least cost effective, most this cost you very less than whatever region we have. Mumbai will cost you more if you use Mumbai region. So we will need region, we will need availability zones. Okay. So we will use two zones, US East 1A and US East 1B. Okay. So these two we will use. Okay. So the first thing we will create is a provider. Okay. So I'll go here and let me just add a file here, main.tf. Okay. So this will be our, and let me delete this one as well. Okay. So that we will create it from fresh. Let me delete this here. Okay. And I will delete this file as well, so that we will create everything from fresh. Terraform state. Okay, we didn't delete it, right? Let me just delete everything so that we, so Terraform destroy. Destroy. Otherwise, I will lose this. So to draw from here. So this will be our so region equal to US East 1. Okay. And inside US is one region. We have two availability zones. Okay. Two AZs. AZ1. Okay. So this is US East 1A. Okay, and this is US East 1B. Okay, so two availability zones. That will make it bigger. Okay, and these two availability zones are part of my VPC. So I just draw this VPC. Go backward. Okay, and this one are my availability zones. Availability zones, and this is my region here. One more round. How do I add you? And I will just send backward and backward and put back. Okay. So this is my VPC. Okay. And inside VPC we have availability zones, and every availability zone have a subnet. Okay. So subnet 1. Okay, and subnet 2. So, okay, so we have a subnet, and when we create a EC2 instance, that is part of a subnet. And before we create a subnet, every subnet is associated with a routing table. Okay, so we will create a routing table. Okay, RT. Okay, and the subnets will be associated with routing table. Okay, and there will be an internet gateway. Internet gateway is part of the region. So when you this internet gateway will be associated with the VPC. Okay, we will also have NAT gateway, which will be part of the VPC. Okay, NAT gateway, and NAT gateway will also have some connection with the subnet. Okay, and when we create a machine, we will create one machine in this subnet, EC2 1. Okay, and there will be another machine, PM1, and okay. So so this infrastructure we will set up with Terraform. Okay, and then you will see how you can organize the code for this whole infrastructure. Okay. Okay, so it is deleted. Now I can safely delete EC2.tf. I can safely delete Terraform states because nothing is pending. Okay, and I can also delete this TFS file because I don't need it. Okay, let me just move it left so that I will access it later. Okay, so the first thing I will do is I create a main.tf. Okay, so I need a VPC. Okay, and before using VPC, I need to define region, right? We need to use some region, right? AWS region. So to define a region in AWS, in Terraform, you use provider, because this is related with AWS provider. You use AWS provider and you define region like region equals to US East 1. Okay. US East 1. I mean, this is the region. Perfect. So we have defined our region. Now the next thing is we need to define a VPC. Okay. So when you define a VPC, you need to choose a CIDR. Okay. CIDR is nothing but the range of IPs the resources will take. Okay. So something like 10.0.0.0/16 we will use. Okay. So every resource in in this VPC will get an IP from this range. Okay. So how do you create a VPC? You can go here. Okay, and you can search for Terraform AWS VPC. Okay. So you can go on the first link and it will show how to create a VPC. In VPC, you have to provide a CIDR block. The same thing you can copy. Let me copy this one, okay, and paste it here. So this will create a VPC for you. Okay. Now you have created a VPC. Okay, you have defined a region. You have created a VPC. Now you need to create two subnets, right? So how do you create a subnet? Okay, you can create a subnet by okay, let me just go to AWS subnet. Okay, so you see here it is under VPC source. So subnet you create by defining this resource, and this resource requires you to specify virtual VPC ID, right? So I'll copy this code. Okay, I'll copy this code. So I will define two subnet. Okay, one is let's go for public only. Okay, I'll say public, and this will be okay. So this VPC ID is coming from this resource. So AWS VPC is the resource type. The name of the resource is this. Okay, and this resource exports a variable called ID. Okay, so ID will be the ID of this VPC that we created. Okay, if you go to AWS console, okay, let me just open from here so that I don't need to open it again. AWS, okay, website. Right. And it here. Okay, if you have any doubt what we are doing, just let me know. Like, I there are a lot of things that you have to do when you create a VPC. So I'm just trying to um, show you what I'm doing. If you have any doubts, if you need any clarification, just feel free to pause. This is like a two-way communication only. So whenever you create a VPC, you will get a VPC ID. Okay, and so we will create a VPC, and this will create a VPC ID for us. Okay, and that VPC ID we will use in our code. Okay. So this is in US East 1. Okay, US East 1 already have a VPC. Let me select this VPC. If it doesn't have anything, I will delete this VPC. Okay, so let me see if we have anything. One subnet. Elastic IP we have. No Elastic IP. So it's better. Okay, I'll delete this VPC so that we don't get confused. Delete. So by default, you get a one default VPC in every region. And this is Amazon managed VPC, but you can also create your own. So we are creating our own VPC. We haven't given it a name. Okay, so let's give it a name. Okay, and let's see if we can give a VPC name. Okay, so attribute reference argument, whatever argument you can give. You can define a tag. Okay, and in tag you can define the name. Okay, so let's give it a name here. Okay, so name I will say my app VPC. Okay, and here say my app public. Yeah, this will create a VPC. So you see why my app we are using same here, but we'll refactor this. Okay, so once you create a subnet, we have created one subnet here. Okay, and now I need a internet gateway. Okay, so how do you create an internet gateway? I'll just copy this one here. So this resource will give you a internet gateway. Okay, you see also here we have to define a VPC that I need internet gateway. Okay, so this will create an internet gateway. Okay, once we create an internet gateway, what we will need? We internet gateway created. Now we need a routing table, right? So how do you create a routing table in AWS? Okay, so routing table is if you go to here. Okay, routing table here. So there are warnings here, which is you can ignore. So this way, if you take this one, this will create a routing table for you. Okay. So egress, internet gateway, routes here. Fine. Okay, let me copy this. We will delete something that we don't need. Okay. So in the routing table, you define what CIDR you will consider for routing. Okay, and where it will route here. Okay. So we have an internet gateway with name main. So internet gateway main dot ID. So this is the gateway ID. So whoever is accessing, wherever the request, if the request is originating from here, it will route to internet gateway. This is what it means. Okay, so I will remove this IPv6 routing. We don't need it. Okay, and here I will just say main routing table. Okay. This is about our default routing table. I'll just call it main. Okay, so see, I have used main everywhere here. Okay, and you will ask me why I have used the same name because you I mean as I told, like, this name has to be unique. Okay, so this, not just this name, like the name of the resource and the type of resource combinedly should be unique. Okay, like this. Okay, so this should always be unique. Okay, so if you use the same name in all the resources, which is fine, but your resource type should be different. Okay, so we have a different resource type everywhere, so I can use main. Okay, so the next thing is, because I have created a routing table and routing table is associated with a subnet, we will create a subnet. Okay, so this is the subnet. I need to associate this routing table with this subnet. How to do it? So I can go here and I will create a association by let me see if I can get that. Okay, subnet association. Yeah. So this code will associate the subnet with routing table. So, let me just go here. Yeah. Okay. So table association, routing table ID, and subnet. Okay. Now to join this routing table and subnet, you will use this code. Okay. So routing table main, routing table association, subnet main ID, and routing table main ID, and I will call it main as well. Okay. I want to keep everything in the same way. Okay. Now you can create a security group as well. Okay, because you are creating a VM, right? We have created a routing table. We have created internet gateway. Let's skip the NAT gateway for now. Okay, because we are creating a subnet, public subnet. Now we will create a VM. Okay, and VM will have a security group as well, right? Okay, so we will create a default security. Every VPC have a default security group. So we will create a default security group that will be associated with this VPC. Okay, so I'll just copy. I have a code here. What I will do is I'll go here and I'll paste it. Okay, so this will be our default security group, and you see it is associated with the VPC. So I have added VPC by default port number 2280, and all the outgoing traffic is allowed. Okay, and it says main security group. Okay, now we will create an instance. Okay, and this instance will be associated with the given security given VPC. Here, when we created AWS instance previously, we did not define subnet ID and security group. Okay, so when we create a VM, right, we don't specify the VPC. Okay, when we create a VM, we define the subnet group. Okay, so when you define a subnet, okay, you automatically associate your VM with a VPC. Okay, because subnet is part of VPC only. Okay, so if you specify subnet, by default you are specifying which which VPC ID you are going to create VM in. Okay, so this VM will be created in the new VPC. New VPC we have just created here. Okay. Okay. So let's see how does this code look like. So AWS admin main, security admin main. Okay, and I'll call it like my app here. Okay, so my app here. I'll just remove this one. Okay. So we have created everything here. Okay. So you see, okay, fine. So my app everywhere here, right? So I have used my app everywhere. We will refactor this as well. Okay, let's open terminal now. Okay, and what I will do is the first thing I will do is Terraform init. Okay, so when you do Terraform init, it says duplicate providers. Okay, fine. So what happened here is I have defined provider here, and I have defined providers here. Okay, so although this is in different file, the Terraform clubs all the TF file into one file in memory, and then it tried to find the correlations. If it says that there are two resources with same name uh, defined in your Terraform code, it will error like this. Okay, so I can remove one of them. Okay, let me remove this Terraform file. We'll just later do it in a proper way. Okay. So let me run this Terraform init. It works. Terraform plan. Okay. So, okay, example.id is not there. So what I do is I'll go to main.tf. Let me see where I'm using as up. Yeah, this is the example. Sorry for that. Okay, let me just run this again. Okay, so it created the coding. Okay, and I can just apply and auto root. This will work. What are the creating route table and route with destination? This operation route create route has to static code chart. So it's into our own more than. Okay. Sorry, my bad. I use 00. I need to use 00 here because it is 00, right? So it says 00. Wait, okay, it can use that one. Route status block. Image ID doesn't work, which is fine. I'll just copy image ID from here. And just click here because it is not able to find image ID. I just paste it here. And image ID can be get from data. Perfect. So it says the destination, this operational whether CID is equal to or more than a specific one of the VPCs. This option only targets only one interface or one node or unlisted. Let's see if that fixes this issue. See whether we check this out. Okay. So let's see if we can refactor this code. And I think after refactoring, this code will start working as well. Okay, so what I can do is I can just use one subnet here. So we can just use 0, 0 dash. Let us see if that fixes. I'm just trying to make it work. Let's see if it works. Okay, it's trying to apply. So basically, when it is trying to add route, it is failing. Now it says, yeah, routing table creation success. EC2 instance operation, run instance, HTTP response start. So the parameter group name cannot be used with parameter subnet. Okay, so that is easier to fix. Subnet ID group. Okay, security group we cannot use. Fine. Okay. Fine. Let's create it. Okay, when you use security group, you can always. Hmm. I'm just trying to make it work. One to add, only instance is pending creation. Now when you will see the instance, okay, let me go to instance, EC2 instance. This instance will not have a public ID, okay, because okay, it should have a public ID, but not now. It is created in a private VPC. We haven't associated any internet gateway to that VPC because if you see this code, right, we have created an internet gateway, okay, but we haven't associated this internet gateway with the subnet. Okay, so we will because of that, this machine is not getting a public IP. Okay? But this is fine. It can access internet via NAT gateway. Okay, via NAT gateway using but you see here the VPC ID here is this one and so on. Okay, but this was not goal for this Terraform session. The goal here is to tell you how to refactor this long code. Okay, here you see at many places I have used my app. Okay, so how you can remove this the hard coding of my app because I'm using it at multiple places. Okay, so what I can do is I can use locals. Okay, and I can say name prefix. Okay, so name prefix I can do like my app. Okay, and this name prefix will be added to you can add to all the names here. Okay, so that if you want to change the name prefix later, you can do it easily. Okay, you just need to do it in one place. So if you want to change something in all the resources, you can do like this. So I will just add it everywhere wherever my app is used. Okay, so this is not my app. My app. Wherever I have used my app, I will use name suffix EC2 instance. Much. Okay. So now if I just do a plan, I'll just do apply and approve. You will see the name will be updated here. Okay, it says 1 to change, 0 to destroy. So it is applying on the my app. The rest will automatically update. Okay, update in place. So okay, so this is how you can use labels. But now this is still very long code. So you see all the codes here. Okay, this is not very good. You have providers here, you have locals here, you have resources here, and there's one type of data block here. Okay, so Terraform give you some standard file naming convention. Okay, so the providers, whenever you define providers, that should go into provider.tf file. Okay, so the provider.tf file is the standard file where you will keep the provider information. Okay, perfect. So you have moved a provider out of it. The locals, right? So whenever you want to create locals, Terraform says create them into local.tf. Okay. So when you have any locals thing, you can create in local.tf. Okay. And if you have anything, if you want to club anything, okay, that is like okay, let's say this data thing, right? So the data will go into data.tf. Okay. Now you have created three files, like four files: provider, main, local and data. Okay. Not local, not locals. Okay. Hmm. Okay. Now at many places we have done hard coding. We have not used variables. Okay. Let's see what are the scope where we can use variables. Okay. So the first thing we can do is we can variabilize the CIDR block. Okay. So we can say that CIDR block you can always change from variables. Okay. So what I'll do is I will call VPC CIDR. Okay. So how do you define variables? You know that you can define a variable using this. Okay. The name of the variable VPC CIDR. Okay. And you can say default value is this. Okay. This one. So this way you have removed the hard coding for new CIDR. Okay. Now you see there is a CIDR block here. Okay. So this is the subnet CIDR block. Okay. So what you can do is you can just replace this with wire dot subnet one CIDR. Why I'm calling it subnet one? Because you may be splitting this CIDR into multiple subnet. Okay. So for that reason, I'm just splitting it up here. Okay. So what I can do is I can create another variable. Okay. And I can call it like CIDR subnet one. Okay. And I can just say default equal to this. So this way you can change it to subnet CIDR. Okay. So what else we have hard coded? We have hard coded the prefix here, which is called main here, right? And let's remove this one. Let's replace this with our prefix here, local name prefix. I will use local name prefix everywhere wherever I have used main as well. Okay. I have security group. Perfect. Okay. So all this thing will be replaced. What else we have hard coded? Routing table. This is fine. This anyway doesn't change much. Okay. Okay. Now this thing. Okay. Now you see here. Okay. So let's keep it here as well. Fine. Okay. So here most of the things are already variabilized. Now we have two variables here. So according to Terraform standard, the variable should go into variables.tf file. So what I'll do is I'll create a variables.tf here. Okay. And I will paste it here. Okay. So this way you moved variables out of your uh, file here. Okay. But let's suppose you don't want to use default values. Okay. What you can do is here you can just say this is type string. Okay, by default it is string, but it is always good practice to specify the values. Okay, and if you don't want to specify default values here, what you can do is you already know there is a tf_vars file, so I will call it .terraform.tf_vars. Okay. here I will specify the variable CIDR. Okay, and another one is VPC CIDR. Okay, so what I will call is it 10.0.0.0/16, and this is like 1.20. Okay, so this way you don't need to define default values. I can just remove them and they will come from Terraform verify. Okay, I can also specify name prefix by or environment. So environment equal to this is like a demo environment. So I will just call it demo. Okay, and this environment I will use in all the resources I am creating. Okay, that can also be done by adding a prefix to the local here. Okay, so I have defined local here. I can put a prefix here like where dot environment. Okay, and this will create like demo underscore my app, demo underscore whatever resources we are creating. It will add a demo in the name. Okay, and I have defined a variable value, but I haven't created a variable here. So let's create a variable here. Okay, and this will be environment. Okay, and this will be type string. Okay, let's try to run this and see if we did break anything. Okay, so I'm just running it here, and it is refreshing state, and you will see that nothing changes, right? So you see it is adding demo my app public, demo my app public, and it will just changing 6 instead. So see here, just by adding the updating the variables and values here, you were able to update VPC, internet gateway, subnet, security group, routing tables, instance, right? All using same place. Okay, so so now you know like how it is how Terraform can help you uh, to to change the infrastructure very easily, right? Okay, so this is perfect. Okay, but one thing which is not good is your Terraform state. Okay, so this is a very critical thing. Okay, so you already know your Terraform state. I mean, this is your Terraform code. Okay, this is your Terraform code. Okay, and this is your AWS infrastructure. Okay, so you created some infrastructure here. Okay, using Terraform plan and apply. Plan plus apply. Okay, so when you create a Terraform AWS infrastructure here, how does Terraform knows that I have applied changes here? It saved the infrastructure state into TF state files. TF state. Okay, so these TF state files are stored in the directory where you run Terraform plan. Okay, so this is by default. By default, all the state of the infrastructure will be saved in your current directory. You see Terraform TF status file is created, and here you will see that the resources that you have created will be listed here. Okay, here you will see it has a VPC main, it has routing table, it has subnet here, association here. Okay, so all this state is present in your Terraform TF state file, but this is in local. Okay, so what happens? So okay, so when it runs the Terraform plan again, okay, this is the code. It runs plan again. Okay, as you already know, it doesn't go to AWS. Okay, it doesn't go to AWS to check the state of the infrastructure. What it does is it checks the TF state file. The TF state file. Okay, so when it checks the TF state file and it sees that I already created so and so resources, and there is some extra resources created here. in the Terraform code. So it will try to create only this infrastructure. Okay, the rest of the infrastructure will not be changed because they are already up to date in Terraform state. Okay, so if it wants to change it, it will apply in the AWS. Okay, and whatever is the information or metadata available for the resources, it will take it and update in the Terraform state file. Okay, so it will do an update in the state once it applies changes in AWS. Okay, so what will happen? Okay, this is a question for all of you. What will happen if I delete this Terraform state file? What will happen if I delete this? Okay, I already deleted. So when I run a plan here, what will happen? Can anyone tell me what will happen if I run a Terraform plan here? What do you, what will you see? You see here, right? What it is showing? It is showing that I have to create 7 new resources. Okay, it says I need to create VPC here. I need to create subnet here. I will need to create a security group here. I need to create routing table here, internet gateway here. Why so? Because it doesn't have a state. Okay, the state file that was storing the state of the infrastructure is no more available here. Okay, and now when you do an apply, okay, and you will see what will happen when you apply it. It will fail, of course, right? It will fail, of course, because the VPC. Ah, okay. Why it is getting created with the same name? Okay, the IDs are different. That is why it is trying to. Okay. So now when you are running this again, okay, and when you go to AWS VPC, you will see one more VPC got created here. Okay, and we'll see it here. I'll click this one, and you see there is another VPC got created here. But the old VPC is gone. Like you don't, this is still there, but it is not available in the Terraform. Okay, you cannot manage that VPC from here because the state file that had this is no more available here. So let me destroy this until, okay, let's try here. And I will need to provide yes here so that it, it's destroying. Still destroy. Okay. So let it destroy and it will make this Terraform state empty. Okay, because it will sync the state of the AWS infrastructure in this state file. And we will see how you can save this state file in a place where you can get it safely. Okay, so now you see the Terraform state. It doesn't have anything else apart from the version and some outputs here. Okay, so Terraform state file is empty because we destroyed everything here. Okay, but again, you still have this VPC here, demo VPC. So how will you get this access? Okay, you deleted the Terraform state. So that is why Terraform state is very important file. If you lost access to Terraform state file, your infrastructure created by you will you have to go and manually delete it. Okay, which is not very not very easy when you create thousands of resources. Okay, so what I will do is I'll just replace here. Did I This is the type profile. Okay. Let me see if I can use this one. Okay. I think I lost access to the Terraform state as well. So what I have to do is I just go and delete this manually to make sure that I don't get costed for it. So when you delete this, you will see that VPC contain one more instance. So I have to delete the instance first. Okay. So this is because I deleted that VPC. Okay, let me just terminate this instance. Okay, this is getting terminated. Okay. And let me just try to delete this again. VPC still away. Until you complete the following action, contain one more instance. Okay, let's refresh it again. Okay. So instance is still getting terminated, it is shutting down. Okay. So while it is getting terminated, we'll see how you can manage the state in a proper way. Okay. So now you so one thumb rule is you do not check in your state file into GitHub repository. Okay. Because this Terraform state contains infrastructure information about your application. Okay. This is sensitive information. If you store in GitHub, other people can check it out or other people can delete it as well. Okay. So it's always better to keep this file in a location where you can access it when outside of GitHub repo. Okay. So for that, Terraform provide you a backend configuration. Okay. Okay. So backend so backend configuration in Terraform allows you to define where you want to store your Terraform state files. Okay. For our case, we will use S3 backend. Okay. Let's see if I can get it here. So S3 backend will store your S Terraform state file in the AWS bucket. Okay. So what I'll do is I'll just copy this code. Okay. And as a standard, the backend file goes into backend.tf. Okay. So I'll create a backend.tf. I'll paste it here. So this tells Terraform that the state file will go to S3 bucket. Okay. And what is the bucket name? The bucket name is defined by bucket here. So what I will do is I'll just say demo my app bucket. Okay. Or what I can do is I can just use Terraform 101. Okay. So this is the TF state Terraform 101. Okay. So this bucket should be unique name across world because your state your Terraform buckets are global resources. Okay. So I just named it here. I need to create this this bucket before I do anything. Let me just delete this. Delete PC. I should be able to delete it. Now all is green. I'll just paste it delete. And now I will go to S3 here. S3. And I'll create that bucket for storing the state file. Okay. So here I will create a bucket. I'll name that bucket like this. Okay. And it will tell me if the bucket is available or not. Okay. All good. That is it. I'll just make it create bucket. The bucket is created. Now I can use this bucket here. I need to, you can define subfolder where you will copy the state. Okay. So I just use a TF, I'll just say my app. Okay. So it will store the Terraform state file in this bucket. Okay. And region is US Eastern. Okay. Now, because your backend configuration has changed, okay, you have to run init again so that it will initialize the backend. So first thing it will do is it will initialize the backend. When you initialize the backend, it will go and create the required folder in your S3 bucket. Okay, so if I go here, okay, nothing created here. Let's do a plan and we'll see if something is getting created here or not. Okay, so what I'll do is I'll just do a plan. Okay, and this time I will delete everything from here so that my Terraform states are not saved locally. Okay, they are created in S3 bucket. So when I do this, it is reading here. It's getting created here, and let's do apply. Okay, so you will see that a Terraform state file will be created at the end of the at the end of the creation of the resources. Okay, so it is creating resources here. It is creating VPC. It is creating security group. So consider like when you want to create a VPC and all this infrastructure from console, you have to go to multiple places, click that button, those button, and then only you will be able to create it. But here, just by running one command, you are able to create the whole infrastructure. Okay, so now it is creating instance. Let it create instance. Still creating. And while it is creating, I'll just do a refresh. Still not here. It will take a little time. Yeah, now it is here. I'll just go to the state. I'll just do a refresh. Now you see there is a my app folder, and inside my app folder, there is a file called oh, so this is a file only. Okay. And this file that is a 17 KB. Okay. So download this file, you will see that this contains the Terraform state that you were using. Okay. And this has opened here. Let me just bring it here. Now this is your Terraform state file. Okay. So your Terraform state file, when you create in S3, they are safe in S3 and you can have versioning enabled here. Even if someone deleted, you can get back from a previous version. Okay. So this way you can safeguard your state file. Okay. Now your state file is not stored locally. You can safely check in all the states. Okay, so that you get uh, remove states. Okay, so we'll just commit it, and that should be sync. Okay, all right. So we talked about the backend. We talked about the refactoring. Now, okay, so now you know that this will create infrastructure. But how about if you don't want to write all this code all the time? Okay, let's say there is a team. Okay, let's say there is a team here. Let's take an example. So we will talk about one more way to modularize your code or make your Terraform code better is like this. Okay, so you are working in a team one. Okay, you have some Terraform code. Some Terraform code. Okay, so VPC, you create VPC, you create subnet. Okay, you create a NAT gateway, you create EC2 machine. Okay, and all the different things, right? So same thing is the same thing is also done by team two. Okay, same thing is also performed by team two. They also create VPC subnet also, right? And there is another team as well, team three. They are also doing the same thing. Okay. Now consider this is one company, okay, and they are writing their code in their own way, okay, and all of them are using the same AWS account, okay, all of them are using same AWS account, okay, and when all the team applies their Terraform code here, okay, their Terraform the resources they create look like some team one AWS and right. Yes, this is the naming convention from team two, team one. Okay, so team two naming convention is like my app and something. Okay, so they use something like this. Okay, team three conventions are like hello y I. Okay. So now when you create, so if you are a IT infrastructure or SRE, right? As an SRE, when you look at this infrastructure code, you will see why uh, what is hack with the team, right? So why they are creating resources with different naming conventions. Okay. So how do you enforce that the team uses the same naming convention uh, across the resources, right? Because you don't have control on the teams. Okay. But what you can do is you can give them a code, Terraform code. Okay. So a Terraform code that will create VPC, that will create subnet, that will create NAT gateway. Okay. That will create EC2 instance. Okay. Simply, this is a Terraform code, TF code to create EC2 machine in new VPC. Okay. So what this is a this is a this is a module. Okay. So what this module does is it creates all this infrastructure, okay, in a standard way. Okay. So what team will do is instead of creating this one, they will just write one line, one Terraform code, which will call. So let's say this is the name of the module is SRE VPC. Okay, or not VPC, SRE EC2. Okay, SRE EC2. So what the team will do is they will call SRE EC2, SRE EC2, and in the SRE EC2 they will say I want name to be team one, so that the team one can know that I have created the instance, right? Same goes for other thing. Same thing is done by team two, okay, and they use team. Okay. Instead of this, they do two. Okay, so same here as well. So team three uses this, and instead of writing their own code, they uses this, and in this way, they all are using the same module. Okay, all are using the same module, and this module creates the resources. Okay, and when this module creates resources, the names that it will create is team one EC2 instance. Okay, when it creates for team two, it's a team two EC2 instance. Okay, team three EC2 instance, and by looking at this naming convention, you will see you can notice that this naming convention is much easier to maintain. Okay, but how do you achieve this in Terraform? Okay, so Terraform provides you a way to define modules. Okay, so there are modules available for Terraform. Okay, what you can do is I'll create a local module, and then you will know you can get a glimpse how you can use that from the Terraform registry. Okay, so what I'll do is I'll just create a module folder. Okay, inside this module folder, I will create a main.tf file. Okay, and this main.tf file will create all the resources that you are creating here. Okay, so I'll just delete everything from here. I'll put it here. So this is creating my VPC and everything. Okay, because we need a naming convention, we'll create a local.tf file. Basically, whatever you have created here, I'll copy in that folder. Okay, so I'll just paste it here. Okay, now everything is here. You only left with main file and backend file. Okay, we don't keep backend file in module because module will not have any state. It's just a reusable code. So I have moved everything here. Now in the main file, you will call this module. Okay, so what you will call, how do you call this module? You call it by module. Okay, and you can say my app. Okay, and here you will define that what does this module requires. Okay, so where is this module? This module is in the directory called module folder. Okay, module folder. Okay, and what does it require? So whatever variables are available here, you can set that variable here so that whenever you call it, it will create a new things here. Okay, so this is the variable name. I'll just need variable name, and that's then I can remove. Okay, so these are the three variables set in the module. So I can choose any subnet. So I will just say 1.0.0 slash 1.24. Okay, if it's CIDR, I can choose like uh 0.16. Okay, and environment I can say team1. Okay, so this is like team1 app. Okay, let's try to run this and see if it works or not. Okay, so in module, okay, you can also create one folder, and in subfolder this will be like this. I will say EC VPC instance. Okay, so this is the module name, and I will copy all of this in this folder. Okay, so that it is easy to manage. So you can have multiple modules as well. So I'll just call module here, and here I will just say VPC instance. Okay, let us now run this code. Now you see I have only have main.tf file. Okay, and this one I can just comment out. I don't need this Terraform web file. Okay, so what I'll do is I'll just run this code, Terraform plan. Okay, and you will see that it will fail for one reason, which I will tell you. Okay, so here it says module is not installed. Okay, so when you use a module like this, not this, sorry. Okay, so let me just close everything. So we are calling a module like this. Okay, so this module should be present in the .terraform folder. Okay, so .terraform folder, just like provider, it will install. It will also install module. When I do a init, it will try to create a module in this folder. Okay, now you will see the .terraform folder also have modules, and this module is oops, okay. It is not getting copied. Let's try to see why. Okay, in the current folder, there is a module and VPC is there. Okay, let's see how. Okay. So just a second. Let's see if I can plan it. Okay. And then I will also tell you how you can use uh, Terraform provided module. Okay. So it says 7 to add, but it says value for undeclared variable because I have defined some variables here. Let's comment it out. Okay, let's comment it out. And now run it again. Okay. Invalid provider configuration. We haven't defined any providers. So providers, sorry, I have kept it in module, which is not good. Okay. So I'll just run Terraform plan again. Okay. Now when you see it, right, it says 7 to add, 7 to destroy. Okay. Because what I have changed is I have changed the CIDR here. Okay. Let me change the CIDR so that it will not delete anything. Okay. Let me change it here and let me just run it here again so that I don't need to change anything. So I am creating infrastructure for team1 and I will show you how you can. Okay. Okay. Let's do an apply and auto approve. Okay. I don't know why it is changing. Most likely it is changing because it's not in the configuration. Okay, which is fine. It's totally fine. So it is destroying and it is recreating again. Okay. So now you see our big code has become only this type of this size of code. Okay. So just by specifying this thing, you are able to create VPC and VPC instance. Okay. And this is because you have moved your reusable code into module VPC here. Okay. Now I want to create infrastructure for team two. So what I will do is I will use team two. Okay. And team two will use a different CIDR. Okay. And I will just make it like team two. Okay. And now when I will apply this one. Okay. Or let's do a plan to see what is happening. I have defined another module here, module call here. It says module not install. Let's do a init. Okay. Now it creates module for this. And let me just do a plan. And just by defining this extra thing, you are able to create infrastructure for team two as well. Okay, it says 7 to add. And if I do approve and apply and approve, it will create infrastructure for team two. Okay, so I can go here and I can show you the VPC. Okay. So now you will have two VPCs for your for the two different teams. Okay, and they are identical in naming. So okay, team two my app, team one my app. Okay, if you go to EC2 instance, okay, EC2 console, you will see a similar naming convention there as well. Okay, I'll just email the VPC ID. Now you see team two my app machine, team one my app machine, right? So this way you are able to create in same kind of infrastructure for two different teams. Okay, and this way you don't need to worry about the naming convention. You just need to define the variables it requires to create a VPC and the instance, and that is all you need to uh, create, call this separate module. Okay, let me destroy this. Open close tab. Okay, I will just go and destroy this. Okay. Right. And just type yes before it asks me. Okay. Okay. Any question so far? Like we covered the modules, we covered how to organize your code. So now you see you don't need to write everything again and again. These both of them are using the same code, and that code is in the module here. Okay. So we created this module by ourselves, but Terraform provides Terraform registry have their own modules available. Okay, so you can browse modules in the registry, Terraform registry. Okay, let me give you the link here. Okay, and here you can see you can create. There's a module called VPC. Okay, and this VPC module which creates VPC resources in AWS. Okay, so by just calling this thing, you will be able to create VPC in this availability, given the availability zone and given the private subnet, public subnet, you want to enable NAT gateway, you want to enable VPN gateway, and what tag you need to copy. Okay, so if I copy this, okay, if I copy this and I paste it here, okay, so I will be able to create VPC, and I don't need this module for me. Okay, I can just directly use a module which is present on internet. Okay, so it will download the module, and now when I do a plan, okay, I can use the module that are available on internet. Okay, so you don't need most of the time. If you so you see it says 32 added. It has whatever code we have written here. Okay, whatever code we have written here, this is already available in this module. Okay, and this module code you can always check out here. So this is the source code of the module. Okay, and you see main.tf here as well. If you open this main.tf, you will see that it has locals here. It defines a AWS VPC. It defines IP4 CIDR. It defines the DHCP option. It has many things that we have not used, and it has also have advanced concept like regex. It uses CIDR subnets. So there are many things. We didn't cover all of this because this is a little complex. Okay, just to give you an overview what is how to use it. So uh, so you can also use a ready-made module for creating your infrastructure. Okay, you see 32 add, and by defining, you can just do pause and pause. So it will not create beacon gateway and that bit on that gateway. Okay. Okay. So this was concept of modules. Okay, you can create like modules like this, or you can use a ready-made module from AWS, which are provided in the registry. Okay. So that I think what else we can cover? I think yeah, this is all we have from the Terraform part. Okay, and during the capstone project, we will see how we can set up uh, the infrastructure using Terraform and deploy an application on it. Okay, so that we will cover in the Terraform. So again, whatever we have done this today, we will also do in capstone project to set up your own application. Okay. Uh, any question from today's session?